Animate and Inanimate by William James Sidis. Chapter 10. Exothermic and Endothermic Substances. To come back to the question that we began to consider, and which we left off in the middle, namely, that of the sort of chemical substances that would be built up under the two tendencies. We will have to distinguish between the case where we are dealing with a positive section of the universe and that where we are dealing with a negative section of the universe. To take the former case first, let us suppose that the positive is the prevailing tendency. This tendency would tend to build up exothermic substances, while the comparatively few cases of the negative tendency would form those same substances into endothermic substances for their own constituency. Some of these endothermic substances, it is true, will be rejected as positive or inanimate matter, but, on the whole, there will be a tendency for the more endothermic substances to go into the negative tendency, or into life, and for the more exothermic substances to be found in lifeless matter. Since each process must chemically build up substances from their elements, which existed as free elements when the world was at a high heat, it might be expected that there might be a tendency towards complex compounds, so that substances tend, to a great extent, to combine with the tetravalent elements, which form the most complex compounds. The two most common tetravalent elements are carbon and silicon, the complex compounds of silicon being extremely exothermic, while the complex compounds of carbons are extremely endothermic. It might therefore be expected that inanimate matter would tend to build itself to a great extent into complex silicon compounds, silicates, such as earth, clay, many rocks, etc., while, on the contrary, living matter might be expected to form as much as possible into complex carbon compounds, as endothermic as possible. Such is known to be the case. In fact, such carbon compounds are generally known as organic compounds. Furthermore, one substance that forms compounds of a high chemical energy, though itself having very low chemical energy, is nitrogen. This element forms extremely endothermic compounds, which are in many cases explosive. At every ordinary chemical transformation involving nitrogen, some free nitrogen goes off into the air, but the reverse process, the fixation of nitrogen, that is to say, the formation of nitrogen compounds from nitrogen itself together with other necessary substances, is a process requiring an immense amount of energy, by one process, a temperature of about 3000 degrees, by another process, a pressure of about 200 atmospheres. Since nitrogen forms such extremely endothermic compounds, we might expect that, where the general tendency is positive, life will tend to include not only as much carbon as possible, but also as much nitrogen as possible. It would therefore, in a section of the universe where the positive tendency prevails, seem to follow that life would tend, as far as possible, to be found in complex carbon-nitrogen compounds. The simplest of these compounds of carbon and nitrogen, itself an endothermic compound, is cyanogen, Cn, and we might expect that the Cn radical would be the foundation of life. On the contrary, where a living body reacts with an inanimate body in any way, it is also likely to build up such complex carbon-nitrogen compounds not only as the living product, but also as the lifeless product which we have seen must be formed. Hence these products must be formed to some extent not merely in living matter, but also in inanimate matter. For instance, this very process of the fixation of nitrogen, that we have already referred to, we might expect to be found accomplished by living bodies which can absorb nitrogen and react with it, leaving nitrogen compounds as rejected matter, besides forming themselves into nitrogen compounds. We do, in fact, find such a process operating among what are called the nitrogen-fixing, or nitrifying, bacteria, which absorb nitrogen and reject non-living nitrogen compounds in a manner that could hardly be explained as anything but reversing the second law of thermodynamics. Thus is the result where the prevailing tendency is positive, and where the negative tendency is the exception. To trace this result further, we must remember that life, the negative tendency, grows by accretion on a living center which is necessary. Living bodies absorb inanimate matter, extending life more and more, absorbing to some extent exothermic substances, rejecting to some extent endothermic substances, until this living activity begins to take in the majority of the section of the universe. Meanwhile the living, the negative, activities will have absorbed most, if not all, of the exothermic substances, while the positive tendency will be kept up by the constant rejection of mostly endothermic substances as lifeless matter. Thus will the extremely complicated carbon-nitrogen compounds tend, in a section of the universe where the prevailing tendency is negative, to be found more and more as positive, as lifeless bodies. Furthermore, since such a section of the universe is the exact reverse of a positive section of the universe, such positive bodies will tend to be formed as exactly such complex organisms as are, in our section of the universe, found in living bodies. We will have a complex, lifelike organism, but with none of the life activities, with some exceptions, as we shall see. We may call such organisms pseudo-living organisms. In our reverse universe, these pseudo-living organisms will take the exact shapes of the living organisms in our real universe. Such extremely endothermic compounds are unstable under the positive tendency, but require the negative tendency to stabilize them. Under the positive tendency, these compounds will tend to decompose into exothermic tendencies very quickly. But the tendency of negative activities to extend from a negative center will be very active when most of the universe is negative, and hence such exothermic substances will be likely to be quickly absorbed by the prevailing negative tendency, while, on the contrary, the prevailing negative tendency will tend quickly to build up as rejected positive matter these same endothermic compounds into the positive, pseudo-living organisms. Thus these pseudo-living organisms differ from corpses in that there is a constant cycle of chemical reaction with the surrounding world, a constant building up and decomposition of substance. Since these organisms are the exact reverse of living organisms as we know them, it follows that, in a section of the universe where the prevailing tendency is positive, any living bodies must exist in the form of chemical machines that constantly absorb inanimate matter, build up into living matter, and as constantly make partial decompositions of their own substance into more exothermic substances which are rejected as inanimate matter. That is, both living substances in our section of the universe and the pseudo-living organisms in the negative sections of the universe have in common the property of metabolism. All these conclusions hold except at a heat so great that the formation of compounds is impossible, example on the Sun. Metabolism is thus not a property of life, but of the minority tendency. The same is true of the chemical composition of organisms. In a positive section of the universe the organisms are living, in a negative section of the universe they are essentially lifeless. Where the heat is too great to permit of the formation of chemical compounds, such chemical machines cannot exist, but the minority tendency, whether positive or negative, would probably exist, the chances of its non-existence being extremely small. Under any conditions the chances are overwhelmingly in favor of there being a mixture of the two tendencies. Yet, though both tendencies are present, there will be a majority and a minority tendency. But what such minority tendency may be like, it is difficult to imagine. For instance, it would be difficult to imagine what sort of phenomenon life would be on the Sun. It would certainly have to be different from any life that we know of, though with the common properties of irritability, apparent teleology, and reserve energy.